Hello everyone. In this presentation, we will be talking about our work, high resolution spatial mapping of soil nutrients using a k-nearest neighbor based convolutional neural network approach. One of the major components of precision agriculture is the precision fertilization. The principle of precision fertilization is to adjust the fertilizer input according to the properties of soils at each location for the least waste and the highest production of yield. This paper presents a feasible approach for developing high resolution spatial map of the soil nutrients based on a k-nearest neighbor based convolutional neural network model. Our CNN based approach is appropriate for mapping soil nutrients because of its ability to predict the soil nutrient value at less computational expense and real-time processing capabilities, unlike the traditional geostatistical methods. We developed high-resolution spatial map of soil nutrients, nitrogen, potassium, phosphorus, organic compounds. Our study area is two districts, Pune and Ahmednagar of Maharashtra state in western India. We used ground truth data available from soil health card database from Government of India. Our approach is to use a k-nearest neighbor information based convolutional neural network where around the location point the k-nearest neighbors information is fed through a CNN model. Considering this problem as a spatial stochastic process, we want to capture the spatial variability in a uniform manner. Here we have described the model input data generation scheme. Suppose we want to estimate the soil nutrient value at the point S0. There are two steps. First, construct a matrix NBRV which contains the k nearest neighbors soil nutrient value. Second, construct a matrix NBD which contains the k nearest neighbors distances from the point S0. For each point, we have NBRV and NBD matrix which are the input for the CNN model. Note that k has been chosen as a positive square integer by looking at the average range of the variogram of the soil nutrients. The CNN model architecture has been shown here where the input NBRV and NBD matrix goes through the model. Convolutional operations are followed and locally connected layer extracts the information from NBRV convoluted matrix, throws the feature information by flattening operation. The distance based information feature is also extracted, then it is concatenated and mixed with the NBRV extracted feature. The output value we can get after two dense layers, nitrogen, potassium and phosphorus. These three spatial variable differs from organic compound, and hence we developed two different architectures having a minor parameter variation, one applied to nitrogen, potassium, phosphorus, another specific to organic compound. The model has been trained with 80% data and tested on 20% data. We performed two experiments with minor parameter changing exercise. The results have been shown here. The maps has been generated with the best parameter settings for each soil nutrients with 100 meter spatial resolution. Keeping in mind Indian small farm size cases so that the grower can take farm level decision. Our approach is inexpensive compared to the traditional geostatistical techniques. It has the potential for capturing the local spatial variability, and it is more accurate than the geostatistical methods. Often it is tedious to find the optimal architecture of the CNN model. It is also not suitable for estimation in larger area because of varying spatial uncertainty. We are working towards further improving the model accuracy and the computational efficiency, and will report in future.